What's up, everybody? My name is Vincent, and today I want to look at a few problems involving irrational numbers. So for these questions here, we want to determine which of these irrational numbers are between 1 and 4. But for a little bit of background, just in case we're not 100% clear on what an irrational number actually is, well, it helps to know the definition of a rational number, which is a number that can be expressed as the ratio of two integers. So, and the denominator is non-zero, so something like 1/2 is rational because 1 and 2 are both integers. I could have -3/4. Even something like 1.5 we could say is rational because it could be expressed as 3/2, or it could even just be expressed as some other multiple of this, like let's say 6/4. So that is one way of explaining why 1.5 is rational. Now, less obvious examples are something like a repeating decimal that has a pattern. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And for this, we could use a calculator. And if we look, 1, 2, 3 repeating is just 123 over 999. And it's just a string of 1, 2, 3s. I could also have something like 4 over 99, which is a repeating 0.040404. So we could take that information from the calculator here and show that repeating decimals can be expressed as the ratio of two integers. And before we had 0.04 repeating, which is 4 over 99. Okay, but irrational numbers are simply numbers that are not rational. That is, there is no fraction representation for them involving two integers. And classic examples are something like square root 2, square root 5. Anytime we have the square root of a non-perfect square, we have an irrational number. Now the calculator will help you see this idea a bit more. So if I take the square root of 2, notice that I have an infinite decimal, but there's no actual pattern here. Nothing is repeating. It's just jumping all over the place. I could also repeat this idea with the square root of 5, and we'll see here, once again, we have a infinite decimal with no pattern to it. Some other good examples to look at would be pi and 3.14159 and so on and so forth. This is a classic irrational number that's very useful in other parts of math. Okay, so now that we have these definitions understood a little bit more, now we're going to get started. Now for these questions, I want to use a few different strategies where we're going to use inequalities and number lines. So I want to determine if pi over 2 is between 1 and 4. Well, I do know that pi is between 3 and 4. Because we just saw a moment ago that pi was 3.14159 and so on, but that's a number between 3 and 4. So if I want to generate pi over 2, I could just divide every number in this list by 2. And what this tells us, well, 3 over 2 is 1.5. Pi over 2 is, we're just going to say pi over 2. And 4 divided by 2 is 2. So pi over 2 is a number between 1.5 and 2. So if pi over 2 is between 1.5 and 2, then it's definitely between 1 and 4 because this little sub-range is between 1 and 4. So this one does in fact check out. So this one, we'll just circle the ones that do work. Pi over 2 is between 1 and 4. Now for the next part here, for part B, we want to see if square root 5 is between 1 and 4. And if we just think of the number line here, 1 is, we'll just say, is at this location, and then 4 is all the way out here. So we'd have 1, 2, 3, 4. But above it, I'm going to write the square root form. So 1 is the square root of 1, 2 is the square root of 4, 3 is the square root of 9, and 4 is the square root of 16. So if we wanted to see where is square root 5, well, square root 5 is between 2 and 3 because square root 5 is between square root 4 and square root 9. So the exact value of square root 5 would be somewhere in this location here. So it's definitely between 1 and 4. So we could include this in our solution. Okay, for this next part here, if we look at part C, we want to determine if square root of 2 over 4 is between 1 and 4. And the way we could start out with this is we know that square root 2 is between And we'll be careful how we say this, but it's going to be between 1 and 2. I want to pick kind of like the smallest range here that I could bound this between. And just in case we're not convinced of this, this is just supporting data, that square root 2 is here. We'll say 1 is here, and this is not drawn to scale, but 1 is equal to the square root of 1, and 2 is equal to the square root of 4. So we could see why that the square root of 2 is some number between square root 1 and square root 4, and that means square root 2 is between 1 and 2, because 1 equals square root 1, and 2 is equal to square root 4. So this inequality is going to hold true here. But then the idea behind part C is that if I want to build the expression square root 2 over 4, I'm going to divide everything here by 4. Okay, so now if we simplify this inequality a bit, well, this is going to tell us 1/4 is 0.25, and that is less than square root of 2 over 4, and 2 over 4 reduces to 1/2, or 0.5. Well, we have to think about this now, because if square root of 2 over 4 is between 0.25 and 0.5, then this number cannot be between 1 and 4, because square root of 2 over 4 is less than 0.5, and 0.5 is less than 1. So there's no way that this number could be between 1 and 4. So we're going to cross this one here off our list. Part D, square root of 11. We could go through with this same idea all over again. We want to get as close as we can to square root of 11. So if we look, well, I'll start here at 2. 2 is equal to the square root of 4. And we have that 3 is equal to the square root of 9. And then 4 is equal to the square root of 16. So now that we have this number line ordered like this, now all we have to do is look, square root of 11 has to be a number between square root of 9 and square root of 16. So that means square root of 11 has to be a number between 3 and 4. So if it's between 3 and 4, then it's definitely between 1 and 4. So we can include square root of 11 in our solution set here. Now for the last question here, this one we could just automatically cross off, because negative square root 3, well, negative square root 3 is less than 0. And if we're dealing with a negative number, we're trying to find values that are between positive 1 and positive 4. So since negative square root 3 is negative, there is no way that this number is going to land between 1 and 4. Okay, well, this is going to conclude this irrational numbers video. If you found this video to be helpful, please click the like and subscribe buttons below. It really helps me grow the channel. And if you got any requests, future video topics you want me to cover, leave them in the comments section below. And thank you for watching.